Welcome back, learners. I hope you had a nice quick rest. Let's continue with our application questions. The first application question we're going to look at is question 1. The table shows the number of hours spent by learners watching TV per day. So we've got the hours on TV per day and the number of learners that watch that TV during those hours. Draw a histogram to represent this information. So we have to draw a histogram. We are given up our parameters there. Then we are given the intervals as well and the exist titles. So it means on our dependent variable, we'll have the number of learners, and on our independent, we'll have the number of hours they spent a day. So now we have to represent this information on a histogram. So between 1 hour to 2 hours, we've got 4 learners. So 4 learners, here is our 4 learners. It's between 1 hour to 2 hours. So it means there is our 4 learners. We draw it like that. And then between 2 to 3 hours, we've got 6 learners. Here is our 6 learners. It means, remember, with the histogram, there are no spaces in between the bars. So it means everything should be clustered together. Then between 3 to 4 hours, we've got 8 learners. 3 to 4 hours, we've got 8. So it means our graph is increasing just like that. We've got 8 learners. And between 4 to 5 hours, we've got 5 learners. 5 learners would be between 4 and 5. So we are given 5 hours there, 4 to 5 hours. Sorry about that. There is 5 learners. Then between 5 to 6 hours, we've got 7 learners, which will be between 6 and 8. So 7 learners is there. Can I just write them down? We've got 5 and then we've got 7 there. So for 7, we have 7 learners watching TV between 5 and 6 hours. And between 6 and 7 hours, we've got 3 learners. 6 and 7 hours, we've got 3 learners. Where's the 3? It's going to be between 2 and 4. So here is our 3 learners. So it's just there. So even with the histogram, we try by all means to make sure that our bar widths are the same according to the intervals and that there are no spaces in between. So there is our histogram. Then question B says, what is the minimum number of hours spent on television? Minimum number of hours spent. So the interval is between 1 and 2. So it means the minimum is actually 1. So it means 1 hour. That is the minimum hour that is spent on television. Then question C, do you think this day was during school holidays or not? Justify your answer. Remember, it's number of learners. So it means then the investigation was done amongst school goers, right? So how do we then see whether this was during school hours or not? So how many hours do learners actually spend at school? They spend about 8 to 9 hours if there are those who are doing extra classes and stuff. So it's about 8 to 9 hours. So if it's 8 to 9 hours in a day, we've got approximately 24 hours. So before they sleep, how many hours before they sleep? Probably, let's say on average, a learner would sleep around 8 p.m. So by the time they come back home at 3 o'clock to 8 p.m., we have a difference of how many hours? Of about 5 hours there. So how do we then see whether they spent more, this time was during school holidays or not? We will check that between 5 to 6 hours, we've got 7 learners, but between 6 to 7, we've got only 3 learners. So it means this is the 3 that is very adamant at sleeping late. So chances are this was not during school holidays. It was actually during normal school time, because if ever it was during school holidays, would have hours about more than 12 hours being on television, because you are sitting the whole day and probably watching TV the entire day. So this was not during school holidays. It was not during school holidays. So remember, with math literacy, we always say it is based on reality. So we try by all means to say, let's analyze question according to reality and check if ever that would make sense in real sense. Okay, remember, so we just answered the first part of the question where we said, do you think this day was during the school holidays or not? We said not during the school holiday. So now we have to justify our answer. Why do we say that? Because the number of hours that I actually spent watching TV are less than the number of hours that would be spent if this was during school holidays. So the number of hours are less than those spent during school holidays. Question 2 says, a graph for the number of learners participating in different sports code is shown. So we are given a graph there with the different sports code to be given there and also the number of learners that are participating in each sports code. Question A says, how many sports code are learners participating in? So we have to count the sports code. So if ever we had one sport code that was at 0, it means we're not going to count it because none of the learners are participating in that sport code. So with each and every, it has a frequency that is above 0. So it means we count the cricket, the soccer, the basketball, and the tennis. So we've got 4 sports code in total. Then the next question says, in which sports code do the majority of learners participate? Majority, which means we are looking at the modal sports code, we are looking at the highest frequency sports code. So if we check that the highest is actually soccer because it is at about 36 learners participating in than all the other all the other sports code. So the sports code is soccer. That is the one that most learners are participating in. Let's do C. C says, identify the sports code for the minimum and maximum number of learners. So we have to check which sports code has the minimum number of learners and which sport code has the maximum number of learners. Then we check which sport code has the least number of learners. How do we see the number of learners? We see it on our dependent variable there. So we check the sports code that has the least number of learners is the tennis. So you write down the tennis has the minimum number of learners, which is how many learners? We check. There we've got about 13 because it is slightly above 10 but below 15. So we've got tennis with the minimum number of 13 learners. Then the maximum, we check what is the highest sports code or the sports code that has the highest number of learners. We have soccer. So we've got soccer. It means most learners prefer soccer, which is our maximum sports code at how many learners. Then we check it is slightly above 35, which we can place it at 36 learners. Then we move on to the next question. Question 3 says, the graph alongside shows which candies do learners like the most. So we are given candies there and it is the flavors and the number of learners that love the different flavors. Then the question says, calculate the total number of candies. Total number of candies will be indicated by the frequency of each and every candy. So we check for the green apple, there's 4 candies. It means there's 4 learners that like the candies. So it means it's going to be 4. And then for the caramel, we're going to have 10 plus 10 plus the butterscotch. It is going to be between 6 and 8, which is 7. So it's 7. And then banana, it's at 8. So now, what is the total? Let's add it together. We've got 4 plus 10, 4 plus 10 plus 7 plus 8. It gives us a total of 29. So we've got 29 candies in total. So let's take a quick break and then we'll continue afterwards.